Hello everyone. So today's class we are going to continue with our permutations and combinations, and the concept of today is based on the rank of the words. So like in alphabetical order, if at all we are thinking, how do you write? Suppose if I give you a letter like C-A-T, cat, isn't it? So when I give you a name like cat, how are we going to represent that in the alphabetical order? So first of all, we will be getting all the words starting with A, right? Later, we will be getting starting with C. That is how we proceed, right? So now, or if you have the A, B, and C letters, let it be. So whenever we have letters A, B, C, so this is the alphabetical order what we have. Suppose if I want the rank of the letter of the word B, C, A letter. Okay, so when do I get? This is my question. Like all the letters starting with A, I will be getting first. That is like A, B, C, and along with A, C, B, right? So these two are done. Next starts with B, right? So now when they're starting with B, I again start with A again. The second position will be filled up with the next alphabet, that is A. So B, A, C, obviously, which I don't want. So next is B, C, A. Now this is my fourth position of the word B, C, A formed by the letters A, B, and C. So if at all they are arranged in this alphabetical order, what is the rank? Where at which position is this word going to come is my question, right? So now for that, my first take will be on the questions based on the words which do not have any repetition. Suppose if I take the word article, A-R-T-I-C-L-E. So are there any letters which are repeated in the given question? Not even a single letter is repeated, right? So whenever we have such questions, now obviously first thing what we need to write is its alphabetical order. So in the alphabetical order, what comes first? Obviously A, next B, C, D, E, F, G, H, I, L, M, N, O, P, Q, R, S, T. That's it? Yeah, right. So this is the alphabetical order in which the given word is arranged, right? That's my first step. Now, in this method, we are going, in this class, we are going to do two methods for this. First method, that is, which is very much essential for your IP board exams, and the other method, which is very, very helpful, the shortcut method for your objective type, right? So coming with the all the letters, see, whenever I have how many letters altogether? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7 positions is what I have to fill in, right? Now my alphabet starts with A, hence I want A in my first position. I want all the letters starting with A, right? So whenever I need A, fix and remove A from your set. From your alphabetical order, you remove that because I'm fixing on A. I don't have to bother much for that. Now I am occupying my second position. Second position will be starting with the C in the alphabetical order. But do I want that? My word should have A R. Right. So when I don't have AR, I have to stop that process and go for my next step. Now, how many words do I have starting with the letters A and C? What's my answer? Now here observe 1, 2, 3, 4, 5. So that's my 5 factorial ways, isn't it? When I fixed A, remove A from there, go with the next alphabet, that is C, right? Later, how many letters do you have and how many gaps do you have? So you have 5 letters with 5 spaces to be filled. Hence, your 5 factorial is your answer there, right? Now go with the next word. Like you will be having A with your first. That is already fixed anyhow. Next will be E. Do I want E? I don't even want E, right? The remaining, obviously, we will be having 5 letters, hence 5 factorial ways. That also I don't want. Next, A with I will be coming, right? So like that, I have to go till A with R. So here also I've got more 5 factorial. A with I also is done. A with L done now. That also 5 factorial. A with R comes now, right? So I completed A with C, with E, I, and L, which I don't want any of them. I want A, R. So fix on A and R. Remove your R from your further combinations there, right? Now, whenever you're fixing on a letter, open the space for the next letter to be filled again with the alphabetical order only. Now, again, the third position also starts with the alphabetical order C, right? But do I want ARC? No, I want ART, right? So stop the process. Now you are left with 1, 2, 3, 4 gaps only. That's your 4 factorial base there, right? 4 gaps to be filled in 4 factorial base. Now coming with the next one, that is A, R, C I don't want. Later after C I have to fill it with E, which that also I don't want. Hence I have left with 4 factorial. So ARE also I don't want. ARI also I don't want. That is again another 4 factorial. ARC, ARE, ARI, ARL now again. ARL, that also I don't want. Hence it's again a 4 factorial. Now comes ART. I do want this, right? So I want this. ART is what I want. Remove that. Open the space for the next position. Now again starts with C. ARTC, which I don't want. I am left with how many gaps here? I think 3 gaps, right? So hence it is 3 factorial ways. Now again, ART fix on them. Next, after C, I'll be getting E, which I don't want. Again, another C, 3 factorial. Now comes with ART with after E, I. Yes, I do want I, isn't it? ARTI. I want I, fix on that. Remove it from there. Okay. ARTI. Yes, I want all these letters. Now open the space for the next position. Again starts with the alphabetical order, that is C. ARTIC. Yes, I do want that also. Now again open the position. Remove C from your list there. Now the next position starts with E from there, right? Now E, I don't want. E with L, that is 1 factorial combination there, or 1 combination, that is just one way. And the final step, that is ARTIC and E, that is 1, right? So now finally, what is the count that I got? How many 5 factorials did I get? I got 4 into 5 factorial base, right? Plus altogether how many ways is what I'm just counting on. So again, another 4 into another 4 factorial base, 4 into 4 factorial, plus 2 times 3 factorial, because we have 3 factorials repeated twice. Again, plus 1, plus 1. So whatever be it, that will be your final answer there. Clear? Now, this is the complete long process what you have to do based on your IP pattern, right? Now, let us go with a one short process for this. Okay, so one shortcut process for getting the rank of the word. See, it is like, I think the total sum is coming out to 114 if I'm not wrong. No, it's not 114. You just check it out and get the answer. I don't have the answer here, right? So you just find out the answer and let me know, right? So now coming for the same answer, but just one trick followed there, right? So first thing, you have to write ARTICLE is what you need to have from the letters of the word article. Now write its alphabetical order just above that. Start with your alphabetical order, that is A, C, E, I, L, R, T. See, generally we'll be going with alphabetical order, so hence preference to be given to alphabetical order. So alphabetical order on the top. Now the method 2 is what I'm going with, the shortcut trick, okay? The shortcut trick to find the answer very easily, right? Now observe what I'm going to do. I'm doing few cuttings and getting the answer. Now how is the cutting done? So A cut with A. You have nothing left before A, hence it is 0 times after this A, you have 1, 2, 3, 4, 5, 6, 6 factorial base. Plus, next cut R with R there. Now, before that R in your earlier count, you have 1, 2, 3, 4 letters. So, take 4 times. After the R here, 1, 2, 3, 4, 5. So, 5 factorial is the base number of ways what you write here. Okay. Now, cut T with T. How many letters you have before L? Oh, sorry, my cutting is wrong. Okay. Cut T with T there, right? So you have 1, 2, 3, 4 letters before that. So hence plus 4 into You have 1, 2, 3, 4, 4 letters after that. So that is 4 factorial again. Next, plus cut I with I. Now cutting I with I, you have 2 letters before that, that is 2 into, you have 3 letters after I, that is 3 factorial. Next, plus cut C with C. There is nothing left, so 0 into 2 factorial. Plus cut L with L. There is just 1 letter left, plus 1 plus. And finally you are cutting E, that also take it as 1. Clear? So finally, what did you get? This anyhow is 0. So this is 4 into 5 factorial plus 4 into 4 factorial plus 2 into 3 factorial plus 1 plus 1. Finish. So the same answer here and here you will be getting it. Okay. So that's how you got the letters of the word article when they are arranged in the alphabetical order. What is the rank of the word article is what you can get it using this short trick process. Clear? Right? So let me go with another question of the same type, right? So that you get more used to the process. Both the process method 1 and method 2 is what I'm going to do. Now take the letter horse. Take the letters of the word horse. Horse. Are any of the words repeated here? Are any of the letters repeated? No, right? So now let me start with its alphabetical order. What is the alphabetical order? So I'll be starting with E, F, G, H, I, J, K. Oh, just a minute. Yes, EHORS is the alphabetical order of writing the given word horse, right? Now, let me start with, if at all I want rank of the word horse, I have to have H in my first position. But my count will be starting with E. Do I want it? It's a 5-letter word. Isn't it? 1, 2, 3, 4, 5, 5-letter word. All the letters, all the words starting with E will be how many? You'll be having 4 factorial such words, right? Next 1, 2, 3, 4, 5. As you don't want E, I again start with H. Do I want H? Yes, I want H. So fix your H on this and you remove H from your block. Open the next place for the second letter that is again starting with E, which I don't want, which I don't want. Hence, you take 3 factorial. The remaining letters can be filled in 3 factorial ways. H I want, E I don't want, O. Next will be O, H, O. Yes, I do want it. Remove from your letter set. H, O. Next, obviously, the third position will be opening up. Now, when the third position opens up, it again starts with the letter E, H-O-E, which I don't want. Hence, it is the remaining 2 letters to be filled in 2 factorial ways. Next again, H-O, the third position I don't want E, I want R. Yes, I do want H-O-R. Yes, remove it from there. H-O-R, open up the space for the next position. Next is E, H-O-R-E, obviously 1 factorial. H-O-R, S with E, that is my 1 factorial, right? Now the same using shortcut process. H-O-R-S-E is what you have to find from alphabetical order, that is E-H-O-R-S. Start cutting carefully. H with H is cut there. So you are left with the towards left of H there. You just have 1 letter. Take 1 into towards right of H here. You have how many letters there? 4 letters, hence 4 factorial is. Plus O with O is cut towards left of O. You just have 1 letter, that is 1. Towards right of O, you have 3 letters done in 3 factorial ways. Plus cutting R with R towards left of R, you just have 1 letter. Towards right of R, that is 2 factorial. Plus S with S towards left, you have 1. Towards right, you have 1. E with E, that is finally 1. Right? So is it the same? 4 factorial plus 3 factorial plus 2 factorial plus 1. The same answer is what you will be getting here as well. Right? Clear? So that is how you got rank of the word with distinct letters is what we have done. Right? The same combination, if at all we have similar letters repeated twice or thrice. Based on that, how are we going to proceed with the same concept? Finding the rank only of the same. That is how we are going to do now, right? Let us start with that question. Now, finding the rank of the word mirror, right? So, and now come in arrangement in the alphabetical order first, okay? O, I, M, O, and R. Okay, so this is my alphabetical arrangement. I have 1, 2, 3, 4, 5, 6 letters, right? Now finding the rank of the word mirror from the given letters, right? So obviously I have to start with I, and I have how many spaces left here? I have 5 letters to be filled. That is in 5 factorial. But when I am fixing on I have remaining 1, 2, 3, 4, 5. All these 5 has got 3 repetitions. Whenever there is a repetition, divided by 3 factorial. Clear? So starting all the words starting with I are 5 factorial by 3 factorial in number, right? Next, I don't want I, right? So I'm going for the next letter, that is M. Yes, after I will be my M only. Yes, I do want M. Fix on M, right? Fix on M. Remove that from your block. Open the space for the second position now. Second position starts again with the alphabetical order only. That is I there. M, I. Do I want I? Yes, I do want I. Right? So click on this, remove I from your set. Now that opens the space for your third position there, right? So M, I, obviously in the alphabetical order, I go with O, but I do not want O. I want MIR, isn't it? So I stop the process. The remaining 3 letters are done in 3 factorial ways upon 3 factorial, isn't it? You are just left with these 3 letters, that is 3 numbers, 3 spaces filled in 3 factorial ways. Along with as there is a repetition of 3, that is 3 factorial there, right? So that's a 3 factorial by 3 factorial. Now again going with M, I fix. Oh, I don't want. Next is R. Fix on that, fix on that, fix on that, right? You want MIR. Next, which opens the space for your next column there. Clear? Next letter. Next letter again will be O in the alphabetical order, which I don't want, isn't it? So now two letters. Now tell me what are the 2 letters which are left there. 2 R's are left there. That is 2 factorial by 2 factorial. Is that clear? Now going with MIR, I don't want O, I will take R will be my next position there. After MIRR, obviously, yes, I do want it, fix it, fix that position also, and then open the space with your next letter, that is O. Yes, you do want it, fix it, and then again go with the last letter R. Clear? That will be just one way. Clear? So that is how you got your answer to be 5 factorial by 3 factorial plus 1 plus 1 plus 1. That will be your final answer there. Clear? So what is your 5 factorial by 3 factorial? 5, 4, 3 factorial by 3 factorial gets cancelled. 5 4's 20. 20 plus 3, that will be your 23 there, right? Now, coming for the shortcut trick for this, right? So, whenever there are repetitions, a slight modification to be done with our cutting there. Understand carefully. Now, this is the alphabetical order to be taken first preference and then your word there, right? Now, cut M with M, the same type of cutting. How many are left before M there? That is 1 letter left. That is 1 into. How many are left after this M? 1, 2, 3, 4, 5. So hence it is done in 5 factorial. But out of these 5 letters, we have 3 letters repetition by 3 factorial. Clear? Next, plus cutting I with I. Cutting I with I, there is nothing left there. So you can just take 0 into any nonsense. That's fine. I'm not writing there. Plus now cutting R with R. When you're cutting this R with that R, you just have 1 letter left. That is 1. And this cutting, how did you do that? 1 R is cut out of how many R's? 1 R is cut out of 3 R's. So it is 1 by 3 is what you have to take. You have cut 1 out of 3 R's. And after this R cutting, you have 3 letters. That is nothing but 3 factorial, out of which 2 are repeated. Hence it is 2 factorial. Right? Next, plus. Now cut R with R again. This one more cutting of R is done. Before which you have one O, one letter, that is one. And here also, out of these two R's, you are cutting one R. So that is again 1 by 2. 1 out of 2 R's is cut here. After which you have two letters, that is your 2 factorial there. Right? Later, O with O is cut. Obviously, O with O, before O, there is nothing left. Hence, what you can say? That is nothing but 0 plus something. Right? That I am not involving there. So 0. Next plus R with R finally plus 1 there. Okay. Now observe, did we get the same answer or not? 5 factorial by 3 factorial. Yes, 5 factorial by 3 factorial plus. This is 0 anyhow. Now observe here 3 factorial by 3 into 2 factorial. 3 factorial by 3 into 2 factorial. 3 into 2 factorial is 3 factorial. 3 factorial by 3 factorial, that is 1. All this will be coming as 1. 2 factorial by 2 factorial, again 1 plus 1 plus 1. Yes, we got the same answer as the earlier one, right? So mirror cutting, did you understand? Right. Now going for the next, there is another word what I would like to go with, and let us stop this and we will be moving ahead for the next concept. If I want to go with A, G, A, I, N, the letters of the word again are permuted. Find the rank of the word again. Let us do a shortcut way only for this, right? So write the alphabetical order first. That is your just above that A, G, I, and N, isn't it? A, B, C, F, G, H, I. Yes, right. So that is the alphabetical order notation, right? Now cutting starts. A with A is cut. There is nothing left before A. So 0 into something, I don't have to do it. G with G is cut. I have one left there. That is one space. And here I have three letters which are different. Hence it is 3 factorial. Plus now I am cutting A with A. There is nothing left before that. Hence it is 0 into something. Cutting I with I, N with N. Finished. What's my final answer there? That's last one is 1. You just have to take it. That is 3 factorial. That is 6 plus 1. That is 7 is what your answer is, right? So if you want, you can try it for banana, B-A-N-A-N-A, right? So write them in the alphabetical order first, A, 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 and we have three A's, 1, 2, 3. Next B with next two N's there, right? Right. Now write down B, A, N, A, N, A down here. Okay, we are cutting B with B, right? You have got three places before A. That is a 3 in 2. Now 1, 2, 3, 4, 5 after B. That is 5 factorial. Out of which what are the repetitions? 2 A's, no, 3 A's and 2 N's. That is by 3 factorial into 2 factorial, right? That is what you take. Next, plus cutting A with A, right? We are cutting this A with the first A there. Obviously start with the same order position. So A with A is first cut. So before A, there is nothing left. So I don't have to do anything. Cutting N with N. Now you are cutting one N out of two N's. Remember that, right? So before this N, I have two A's there. So that is a 2 into 1 N out of 2 N's are cut. Later you have left with 3 letters with 3 factorial by 2 A's are repeated. Hence 2 factorial there. Clear? Next, cutting this A with that A, nothing is left. Cutting N with N. I am cutting, before that N, I have one letter, right? So 1 into, I am cutting that 1 N into, I am left with only 1 after which that, okay? Next, plus A with A there. That is one final answer there, fine. So finally, answer will be, you just have to do. Now it's like until now we are discussing, like I am giving you a word and I'm asking you to find what is the rank of that word, right? What is the rank of that word is what I'm asking you to find. Now what I say is what will be the word in the 51st position, or what is the word in the 101st position? That is how I'm going to ask you. Like what is the word in the 23rd position? That is how I'm going to ask you, right? So for that, You just have to frame the word there. Which word will be coming there is what you need to understand, right? So for which I'll just take one example. Let me go with the same word. Yeah, the again AGAIN is what I'm going to go with. Right. Generally, total how many words do we get? Can you tell me? Total from this again 1, 2, 3, 4, 5, 5 letter combination, 5 factorial upon we've got 2 A's, that is 2 factorial repetition there, isn't it? 2 A's are there. So that is 5 into 4 into 3 into 2 factorial upon 2 factorial. What is it? 5 fours 20 and 20 into 3, 60. 60 total words are formed from this, right? Now my question is, which word is in the position 51st position? Which word is in 51st position? Okay, na? So that is what we have to check. Out of 60 words, which is the 51st position is what my question is. I cannot keep writing here, right? So I need to have a thought there. Now I am starting with the letters A, right? One, two, three. Basically, I have one, two, three, four, 5 letters. So 5 letters, I'm starting with letter A. All the words starting with the letter A are how many in number? We have got 4 factorial there. That is 24. So 24 words are done with this combination, right? Next, do I go with the letter G now? Right? Starting with letter G. Now, starting with letter G, tell me, when I'm fixing on G, I've got 4 letters remaining, of course, 4 letters remaining, but out of these 4 letters remaining, 2 are repeated there. So hence it is 2 factorial. That is 24 by 2 factorial, that is 12. In your rough, just keep adding them whether I'm reaching my 51 count or not. 24 plus 12, how much is it? 24 plus 12. In your rough side, you just do it. That is your 36 count. I can still more further go. So now A, G is done. A, I cannot repeat. All the letters of the word that are starting with I take. 1, 2, 3, 4. Again, take another count. I just, if at all they are starting with I am left with 4 other letters with 4 factorial by 2 factorial because 2 A's are repeated there. Hence, I got a 12 again there. Now add 12 to this. Yes, you've got 48. You can still more further go. So till 48 letters, all the 48 words are done till now. Now starting with letter N. If I'm going with letter N, all the letters of the word starting with letter N, if I take what 1, 2, 3, 4. Again, if I add another 4 to this, think about it. If I add another 4 to this, that means another 4 factorial by 2 factorial. If I add, that is again another 12. If I add, what do I get? I get 60 count, which is crossing my 51. So from here, I have to open my position for my next place. Remember that. Clear? So open the position for the next place because you cannot take all the letters of the word starting with N, which is crossing your 51st position. Now, when you're opening up your next position, that also again begins with your alphabetical order only there, right? So I am fixing on N and A. I am left with 3 letters here. And with A, the 3 remaining letters are G, A, I. All 3 are distinct. That is 3 factorial. That is 6. Yes, I can keep counting. Now, what is the sum of all this? Count and tell me, right? So if I go with the sum of the, see, I just want the 51st position there. If I add 6 to that, 48 plus 6, I'm going to 54th position. No, I cannot go with that, right? So hence I have to take another position also. This should not be my choice. Open up with the next position there, right? Understanding? As you are crossing your 51st position, you cannot go with that. Remember, count till here is 48. If you are opening up your second position, you got 3 factorial. 3 factorial is 48 plus 6, which is crossing your 51. So this also I am not supposed to take. Open the next position after N and A, right? After N and A, you will be starting again. Your next position starts with another A, I guess, right? The third position, 1A is fixed here. Third position starts with another A there, right? So you've got only 2 factorial ways, right? So that is 2 factorial is absolutely fine. 2 factorial is 2. Now when you're adding them, 48 plus 2, now 50. 50 is done, remember. 50. Now you just have left with 1. So now NA, after this A, third one is what? You can go with, or else you will be going with G. When you are going with G, what do you get? Go with G now. So after this NAG, you've got two letters there, isn't it? So NAG in the sense two letters, again another 2 factorial ways. So that will be coming to 48 plus 250, 50 plus 252. So do not go with that. Open the next position there. So NAG is done. Again, you start with A, I. That will be your next one combination, right? Till here, how many did we get? 8 plus 250, 50 plus 151, finish. NAGAI will be your 51st rank. Understood how to get it, right? So think very carefully and attempt such questions. What is the word in that 51st position will be your questions type, okay? Another question also we will be doing based on this. Now, a similar question to the previous one. So, what will be the word that comes in the 59th position if all the letters of the word bring are permuted, right? So, what is the alphabetical order here? A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R. Yes, this is the alphabetical order, right? Now I am starting with, I have a 5-letter word, clear? So starting with the B, all the other 4 letters can be done in 4 factorial ways, that is 24. Keep it aside. Next, starting with B is done, remove it, go with G, right? Now when I'm going with G, I have another 4 factorial ways, that is 24. Keep adding and check whether you're crossing 59 count or not. That is 48, it's still okay. Next, after G, if I go with I get another 4 factorial, 24, 48 plus 24, which will be crossing my 59. Hence, I cannot go with just with I have to open my space for my second position there. Clear? So, after I am fixing on I. Now, remove this I from your block. Go with B again here, right? Again from the alphabetical order. Now you are left with 3 there. So hence it is 3 factorial, which is 6 there, right? So now plus 6, 48 plus 6 will be how much? That will be your 54, right? 54, absolutely fine. After I, if I go with the G here, another 3 factorial, that is 6, 54 plus 6. So that will be crossing my answer. 54 plus 6, 60. That is crossing my answer. Hence, I need to open my position for my next value there. So I done, G done, again with B here. I am left with 2 more positions there. That is another 2 factorial is what I can take. That is 254 plus 256, no problem, right? So am I going in a count way, proper way? Yes, 50, just a minute. This is 48, 48 plus 6. Yes, 56 till here is fine, right? Now I go with I, G. If not B, I and G are fixed now, right? If not B, I have to go with N. Next position will be N only. Another 2, no problem for me? Yes, fine, absolutely fine. Another 2 also, no problem. That is 58 is my count till now. The very next value is my answer. So I, G, after N, that will be R. Later again come here. IGR is done. IGR is done. B with N. That will be my 1. That will be my 59th word. IGRBN is my 59th word from the given. Clear given letters of the word bring. Now the next coming questions is like I am giving you some 6 digits, that is 0 to 5. 0, 1, 2, 3, 4, 5 is the digits what I'm going to give you. Now I want you to frame number of 5-digit numbers. How many total number of 5-digit numbers can be framed from the given 6 digits is my first question. See, here 0 is included in the case. When the 0 is included, it's a different case altogether. What we have to solve it very carefully, right? Next, number of 5-digit numbers which are multiples of 2 5-digit numbers divisible by 5 5-digit numbers, multiple of 3 5-digit numbers which are multiple of 6 and multiple of 4 is what we have to choose. All these questions is what we are going to solve in one shot, right? Now coming for total number of 5-digit numbers. See, observe very carefully what I am doing. 1, 2, 3, 4, 5 places is what I have to fill in. Now tell me, can I fill the first place with 0? Can I have a 0 here? No, right? I cannot have a 0 there. So my first place is occupied with the remaining 5 digits only. I've got 5 options to fill there. Now, how about the remaining 4? Remaining 4, I am left with 5 digits now. 1 digit only I'm fixing here. Suppose let it be 1 I'm fixing there. So I'm left with the remaining 4 digits there. So all these remaining 5 digits there along with 0. So 5 digits along with those yeah, along with the 0 included there, I can place anywhere. I have 5 digits, I have 4 places. So is it 5p4 there, right? So my final answer will be 5 into 5. You reduce it 4 times. 5, 4, 3, 2, right? That will be your answer. Now, instead of doing it this way, when I have 0 in my count, there is another possibility to do that. 1, 2, 3, 4, 5. I want 5 digits, right? So my answer from the 6 digit number is what I want. Generally, if I have, suppose 0 is not there. If 0 is not there, what is it? It is out of 6. You are arranging 5. That means, is it 6p5 there? Isn't it? This is the basic thing what we do. Out of 6, we are arranging 5. Now, whenever 0 is there in our case, one shortcut process, instead of doing all this, we can do one thing, that is reduce 6 by 1, that is 5. P, reduce 5 by 1, that is 4. Just reduce the 6 and 5 by 1 each. 5p4 is what you do. Which means you are actually removing the 0 as your first option there. Right? Now just think about writing this answer here. What is 6p5? 6, 5, 4, 3, 2 into 1. 6p5. Yeah, that's it. 6 reducing it 5 times. Minus 5p4, 5, 4, 3, 2. The product of these. Now if you remove 5, 4, 3, 2 common, you are left with 6 there minus 1 here, which is again 5, 4, 3, 2 into this 5, which is same as your earlier answer. Did you check that? Right? So what I would suggest is, so whenever 0 is there in your case, no need to worry on that. Just think about a question without having a 0 in that. How would you do? Apply the same. Later, that is your 6p5. If you think that you have 6 digits, you have to pick any 5 digits and permute them or arrange them. You will just write 6p5 there. That is what I have written here, 6p5. But later, as 0 is there in our case, please do remember one thing. 0 is there in our case. Remove that 0 in the sense, reduce 6 by 1, reduce 5 by 1 and write 5p4 there. Subtract 5p4 from your answer. Clear? Now, think about the next question. The next question is of the same type is what we are going to solve. How are we going to solve? 5-digit number which are multiples of 2. 1, 2, 3, 4, 5. Clear? Now I have 5-digit numbers is what I do. I need it to be a multiple of 2. Tell me if it is a multiple of 2. How should I proceed? If it is a multiple of 2. I am having my options to be 0, 1, 2, 3, 4. Okay. So basically it can be units placed should be my even number, right? So 0 or 2 or 4. See, this case is when repetition is not allowed, right? So it should be the 0 or 2 or 4. If 0 is there here, one case, you solve it separately. 1, 2, 3, 4, 5. If 0 is not there, that means you will have even number in the sense you should have either 2 or 4. Either 2 or 4, which is two possibilities here. Either 2 or 4, right? Now tell me, 0 is here. You are left with 4 digits to be filled from the 5 digits. So is it 5p4? And this 0 is done in one way. So altogether answer here is 5p4 into 1 plus. Now here, when you have 2 or 4 here, you have two possibilities. Now you need to fill up 4 from the remaining 5 digits. Remaining 5 digits, 4 you need to fill. That is 5p4. But 0 is there in this count here. You'll have a 0 here, which means minus 4p3 is what you do into this 2 there. Finished. So sum of this whole and this whole gives your answer there. Understood? So that is 5-digit number which are multiples of 2 there. Right? Next, coming to 5-digit number that is divisible by 5. Again, 1, 2, 3, 4, 5 with units placed as 0. 1, 2, 3, 4, 5 with units placed as 5. Divisibility by 5. The rule is that only, isn't it? Now what? What should I do? When you have 0 here, obviously you are left with 4 options. 0 is not there into your arrangement right now. So 4 options to be filled with the 5 possibilities there. So count here will be 5p4 into 0 in that last place is just one way. Clear? Now when 5 is there here, 0 will be somewhere over here. 0 will be somewhere over here. When the 0 is there in your case, always remember you have 4 spaces for 5 possibilities. It is 5p4, but remove your 1, that is 0 case, that is a 4p3 into this one way. 5 can be filled there in only one way. Now addition of this plus this whole will be your answer for 5-digit numbers that are divisible by 5. All this sum is what you have to do. What is 5p4 plus what is 5p4 minus 4p3 and all. You please do it on your own. Right? Next, coming for 5-digit numbers which are multiples of 3, which are formed by the digits 0, 1, 2, 3, 4 and 5. Now, if at all a number is a multiple of 3, if it is divisible by 3, we need to understand what here? What is the first thing that we need to understand? Sum of all digits should be divisible by 3. Now, from these given 6, pick up any 5 such that their sum to be divisible by 5, right? Suppose if I am ignoring 0, tell me 1, 2, 3, 4, 5. This is my case 1. Right? This is case study. So 1, 2, 3, 4, 5. I have 5 digits. All their sum is divisible by 3. Yes. 1 plus 2 plus 3 plus 4 plus 5. Yes, it is divisible by 3. That is one possibility I can have. Or I can also have, suppose if I am removing 3, I'll place 0. 0, 1, 2, 4 and 5. Here also all my count. 5 plus 4 is 9. 2 plus 1 is 3. Yes, it is divisible. Perfectly divisible by 3. Or if I remove any one and place anything else, is that possible? My case 3, is it possible there? Try to remove any one digit and place another digit into that and check whether it is divisible or not, which you will not find it. Clear? So my option is only in this case and in that case. Now from these 5 numbers, I can arrange them in any way. I need a 5-digit number only. 5 digits, 5 numbers can be done in 5 factorial ways. Is that clear? Answer for the first case is 5 factorial. Now coming here, I need to place 1, 2, 3, 4, 5, a 5-digit number from these given digits, that is 5 factorial ways. But as I said, 0 is included, remove 1, that is 4 factorial is what you remove. Basically 5p5 minus 4p4. That's it. So either way, 5p5, arrange 5 out of 5 minus 4p4, it's one and the same. Clear? So now this sum of 5 factorial ways plus 5 factorial minus 4 factorial will be your answer there. Is that clear? Right? Yeah. Just a minute. Well, now my fifth question is a 5-digit number which is a multiple of 6. Isn't it? When it is a multiple of 6, see, multiple of 6 in the sense divisibility by 6 is the number should be divisible by both 2 and 3, right? So 3 divisibility is what we just checked, right? So the same 2 cases. The first case is with 1, 2, 3, 4, 5. The second case is with 0, 1, 2, 3, 4. Oh, sorry, 0, 1, 2, 4 and 5 digits is what we are choosing, right? So now in this 1, 2, 3, 4, 5-digit number is what I am choosing, right? Now, as I said, it should be divisible by 6 in the sense it should be a number which is divisible by 2 as well, right? 2 in the sense last place to be my even. Even possibilities from my given options. So 1, 2, 3, 4, 5. Even possibilities is just 2 or 4 which can be filled in 2 ways, right? The remaining 4 digits with the remaining 4 digits there which is done in 4 factorial ways. So finally answer there from the first case is 4 factorial into 2 factorial. right? Now coming here, the case is again split into two. Reason being what? You have 0, 2, 4 as your even places, right? So here it can be 0 or 2 or 4. But I cannot count all of them in the same way, right? What I do is 1, 2, 3, 4, 5. Right, I'll take 1, 2, 3, 4, 5 with 0 in my first case as my units place or 2 or 4 as my units place here. Got it? Did you understand what I'm doing? Right. Now, in this case, what are my options? If 0 is there, obviously, what is the scene here? 4 factorial. Isn't it 4 places? 4, that is 4 factorial. Or if it is 2 places here, 0 is there in this case. That is 4 factorial minus 3 factorial into 2. So, finally, this plus all this should be your answer there. Right? So basically for my divisibility for 6, the first case is what? 4 factorial into 2 factorial. That is one thing. And the second case is again split like this plus this. All this you need to add them and get your final answer here. Okay. Just check very carefully. Right. Next, what is the other question that I have given? Yeah. Let me go back. Yeah. And now I have given you one more question. I think that is my sixth question. That is 5-digit number which are multiples of 4 from the same digits. That is your 0, 1, 2, 3, 4, 5. Yes. So from the digits 0, 1, 2, 3, 4, and 5, I need to frame 1, 2, 3, 4, 5-digit number, right? For divisibility by 4, what do you mean by divisibility by 4? While a number is divisible by 4, obviously your last two places, that should be a number which is divisible by 4, right? Last two places should be divisible by 4. Now, start with 0 onwards. Check every possibility there. 0, 1 divisible? No. 0, 2 divisible? Yes. No. No, no, no. 0, 2 not possible. 0, 3? No. 0, 4? Yes. 2 digits is what you need to check. 0, 5? No. Now check with 1. 1, 0? No. 1, 2? Yes. Divisible. 1, 3, no. 1, 4, no. 1, 5, no. Next, 2, 0. Yes, it is divisible. 2, 1, no. 2, 3, no. 2, 4, yes. Clear? 2, 5, no. 3, 0, 3, 1, 3, 2. Yes, 3, 2. 3, 4, 3, 5, no. Next, 4, 0, yes. 4, 1, 4, 2, 4, 3, 4, 5, no. Next, 5, 0, 5, 1, 5, 2, yes. 5, 3, 5, 4, 5, 5, no. Clear? Out of all this, 1, 2, 3, 4, 5, 6, and 7. So we have 7 possibilities there, right? Now, in this, what are all the possibilities with 0 is what you have to trace and keep it aside, isn't it? 1, 2, 3, 4, 5. With zeros, 0, 4, 2, 0, 0, 4, 2, 0. I'm just marking them. 0, 4, 2, 0, and 4, 0 is one case you have to split. Next, 1, 2, 2, 4, 3, 2, 5, 2. Right? That is another case what you have to take. Why? Because 0 coming into case is one option, 0 not coming into our case is another option there. Right? For these, yes, let me talk about the first case. First case, what will be my answer there? Yes, in this, these are all 3 ways, right? So 3 ways from that into the remaining 3. As we have already 0 placed it there, I have one, yeah, no repetition allowed there, right? So we are just left with 3, right? 3 from how many digits? What are the possible options for me? I have placed only 2 here. I have 4 options left with 3 places. So is it 4p3? So that is my 4p3 into 3 is my answer from the case 1, right? For multiples of 4. Now for 4, the next case, this is my case 1 answer. Now coming for the case 2 answer. I have 4 possibilities here. Fine, absolutely fine. Now observe, 0 is there in my choices here, isn't it? There is no 0 here, which means 0 can be here, right? So I am left with, see, I have fixed only 2 digits from my given 6 digits. Fixing only 2 from my 6. I am left with 4. 4 digits, 3 possibilities there. So is it 4p3? But as 0 is there in my case, minus 3p2. 1 less, you subtract and write your answer there, right? So that is finally 4p3 minus 3p2 into 4 is your answer from your second case there, right? This will be your answer from your second case. So adding first case plus second case gives your answer for 5-digit number, that is multiples of 4 there, right? While adding, you just count both the ways, that way and this way. The first case and second case to be added, that will be your final answer there, right? Now, all this set of questions is what we have done when there is no repetition of the digits, right? So, almost all the possibilities, 5-digit number, which are multiples of 2, 3, 4, 5, and 6 is what we have completed, right? Now, with the same set of 0, 1, 2, 3, 4, 5 digits, now I am going to write the numbers with the same set of questions, but when there is a repetition of the digits, what are we going to do, right? Now, let us start doing when there is a repetition. So when 0, 1, 2, 3, 4, 5 can be repeated any number of times. They can be repeated any number of times. Now, what is the total digits formed? Total 5 digit. I'm talking about only 5-digit numbers. Okay, na? Total 5-digit numbers formed is my first question. Like the similar way of solving for the previous set of all the 5 to 6 questions is what we are going to step back again. 1, 2, 3, 4, 5. 5-digit numbers as what I said. Now this is my 5-digit number with the digits 0, 1, 2, 3, 4, 5. Yes. Now tell me, my first place can be filled with 0? No, isn't it? So I have 5 places only there, 5 options only there. So first 5 there. Next, rest all 4 digits. Each and every place can be filled with any of these 6 digits. Doesn't matter for me at all, right? So I have all the 6. I can have 0 also here, right? So I'll have all the 6, 6, 6 and 6. Now final answer will be 5 into 6 to the power 4 will be my answer here, right? So that is my total digits, 5 into 6 to the power 4, right? Now question number 2. That is 5-digit number which are multiples of 2. Now check out this one. Multiples of 2. 1, 2, 3, 4, 5. So multiples of 2. We have to divide the case 1 and case 2 is what I said earlier, right? So if it is multiples of 2, can I have, see, in this possibility, do I have to divide or not? You just think about and tell me. As I said, 0, 2 or 4 are the possible cases. So anyhow, I can have any of my 3 values only here. It can be either 0 or 2 or 4, right? And the first place can be filled in only 5 ways. I cannot have a 0 there, right? So that is how I got 5 here and 3 here. And these 3 remaining can be filled with 6, 6 and any of these 6 digits, isn't it? Right? So my final answer here will be 5 into 6 cube into 3 will be my final answer there for multiples of 2. Is that question clear? Right? Now I am going with multiples of 5, let it be. Now coming for multiples of 5, think about it. 1, 2, 3, 4, 5. I can have a 0 or 5. That's it. Nothing else I can have there, right? I can have a 0 or 5. This can be done in 2 possible ways, right? Because it is multiple of 5. Now my first place can be filled with all the 5 or only 5. All the 6? No. I can place it only with the 5 digits there. Okay. 0 should not be coming into that place. Now these 3, 6, 6 and 6. So is it 6 cube there? So 5 into 6 cube into 2 will be my answer there, right? Now I am going with the multiples of 4. Now when I'm talking about multiples of 4, do it very carefully. 1, 2, 3, 4, 5. Multiples of 4, as I said, the last 2 places should be divisible by 4. Now tell me what are the possibilities for the last 2 places when there is a repetition of the digits 0, 1, 2, 3, 4 and 5. There is a repetition. You can count it any number of times. So the last 2 places can be filled with all the possibilities is what I'm writing here. 0, 0, absolutely fine. 0, 1, no. Next is 0, 2, no. 0, 3, no. 0, 4. Yes, isn't it? 0, 5, no. Count it in a proper way so that you won't be missing on any of the numbers there. right? So 0 with all these combinations is what done. Next comes 1 0, 1 1, 1 2, yes, isn't it? 1 3, no. 1 4, 1 5, no, right? Next 2 0, yes. 2 1, 2 2, 2 3, 2 4, yes. 2 5, no, right? Next 3 0, 3 1, 3 2, 3 3, 3 4, 3 5, no. Next 4 0, yes. 4 1, 4 2, 4 3, yes. No, no, 4 4, yes. Next 4 5, no. Next 5 0, 5 1, 5 2, yes. 5 3, 5 4, 5 5, no, right? So all these are my possible count. Anything missing, just check once. Right. So now, yeah, it is now all 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possibilities there, right? Now, my first place, obviously, I cannot fill with all the 6 digits. I just have 5 options. 0 cannot be placed here. So it is only 5 possibilities. These two can be any 6 digits, no problem at all. So my final answer here is 5 into 6 square into 9 will be my final answer. Okay. 5 into 6 square into 9. So that is the total number of possible 5-digit numbers which are divisible by 4 when there is a repetition of the digits allowed any number of times. Clear? Now I am going with 4 cases done, right? So I have completed multiples of 2, 5 and 4. Multiples of 3 is what I am going to do now, right? Now let us start with the multiples of 3 with the same 5 digits. Next. Coming for multiples of 3 from 0, 1, 2, 3, 4 and 5. Obviously, what was our selection earlier? It can be with 0 or without 0. With 0, if it is 0, 1, 2, 4 and 5, that is my case 1. Without 0, if it is, that is 1, 2, 3, 4 and 5, right? So now, using this pattern, 1, 2, 3, 4, 5, there is no problem for me at all, isn't it? Because all the 5 digits, 1, 2, 3, 4, 5, all these 5 digits can be filled with any of these 5 digits, no problem. That is 5, 5, 5, 5, 5. My final answer from here will be 5 to the power 5 ways. Now the problem comes with the place where, with the case where we have 0 included in that. For that, what should we do? Let us check. Right. So now what I'm going to do here is my first place, as I know very well, I am given only these options. I'm having 0, 1, 2, 4, 5 now. This is my case 1 and my case 2. Case 2 is very easy. Case 1 coming here. I cannot have a 0. I can have any of my other 4 digits here. So 4 there, possible cases, right? Now try to understand carefully this part. These 3 numbers can be filled with any of the digits I will take. All the 6 here, all the 6, no, no, sorry. All the 1, 2, 3, 4, 5 possibilities. There is what is I'm given with, right? Well, if I am doing this in a case 1 and case 2 notation, I might have a numbers which are repeated in my case 1 and case 2. So let us not go with the case 1 and case 2. Directly, we will be going with one case only. Yeah, let us, because there will be some repetitions which we cannot count on, right? So I am going with now, let me take 0, 1, 2, 3, 4, 5. All my 6 digits are taken into consideration for framing 1, 2, 3, 4, 5. A 5-digit number which are multiples of 3 is what I am going with. Obviously, my first place cannot be 0. Hence, it is 5 ways. Fix it. Now, these 3, you fix it with any of the 6-digit, no problem at all. Any of the 6-digit you take. That is 6 into 6 into 6. Right? So, all this is fine. Right? Now, my last place is what I will keep it and I will try my combinations on this. So what could be the possibility for my last case? Okay. See, I already filled 1, 2, 3, 4. 4 digits is what I already filled. My last option is what I am checking. Now, try to place any 4 different 4-digit numbers. Let it be 3, 1, 4, 2. All these are different, right? So what is my option left with the last place? You tell me. When you add these, what do you get? 4, 5, 6, 7, and 10, right? 10, what should be your last digit such that it is divisible by 3? After 10, what is the number that is divisible by 3? That is 12. So here you should have a 2, or it can also be plus 3, you take it, or 5. So now if you observe 3 plus 1 plus 4 plus 2 plus 2, yes, it is divisible by 3. 3 plus 1 plus 4 plus 2 plus 5, also divisible by 3. So for my last option, I have two possibilities. This is when all the four digits what I took earlier here are different from one another. Now what I will pick is, let me pick up two equal numbers and two different numbers and check out the possibility for the last place, right? Now, what is the sum? Count it. 3, 4, 5, 6, and 7. You have 7. What will be your other digit so that it should be divisible? 7 in the sense 7 plus 2 only gives me 9, which is divisible. Plus 2, or 2 plus 3 again. When it is divisible by 3, you have to keep on adding 3 there. 2 plus 3, yes, 5. It can be either 2 or 5 in this possibility also, right? This is when two digits are repeated, two are fixed. Now, if I am giving you three digits repeated, if I am giving you three digits repeated, that means let me take 2, 2 and 2 with some 3 here. Let it be. I am giving you three digits repeated. What is my option for my last place is what I am checking. 6 plus 3, which is 9, isn't it? 3, 6, 6 plus 3, 9 perfectly divisible. Hence, it can be either 0 or 3. Isn't it? That's it. You cannot have a 6 here, which is 6 is not there in your options at all, right? So you have only two possibilities there. If three digits same, alike, and one not like. Okay. Next coming for two same and two same. The next possibility. Try all the possibilities. Don't leave any possibility. Right. You can try for two twos and two threes. Now check what is your possibility for your fourth place. Here you have 4. Here you have 6. 6 plus 4, which is 10. 10 key, you just have to add 2 or 5. That's it, isn't it? Hence, also you are getting only two possibilities there, right? So we have tried all the possibilities, isn't it? Whether all the four are same also, that also you take it. 2, 2, 2 and 2. All the four are like I am taking, right? The first remain. Now 8. 8, the last place should be 8 plus 1 only divisible by 3, isn't it? So last place can be 9. Last place can be 1 because you already have 8. 8 plus 1 only gives you 9, or plus 3, 4. So 1 or 4. So in every such case, what did you observe? You found that this last box has got only two options. You have tried all the possibilities. Here you tried all distinct. Here you tried all two alike, two distinct. Here three alike, one distinct. Here two alike, two distinct. And here all alike. So each and every possibility is what you checked. You ended up with the last place having only two options in all the cases, right? So my final answer will be 5 into 6 cube into 2 will be my final answer. Final answers is what I am not writing. You please do it. Clear? So for multiples of 3, rather than checking two cases separately, unlike we have done in the earlier case, that is without repetition, there it is mandatory to do that. But here, you don't need to do that. But if you are doing it in that two cases, you are getting some numbers which are repeated, which you cannot trace them back. Hence, do it directly with these given 5 digits only, you will be getting your answer, right? So your last place will be getting only two options irrespective of what nonsense you are giving for the first four places there. Clear? Understood that part? Right. Now, next question will be what? Multiples of 6, isn't it? Multiples of 6 when we are trying. What do we want here? When we are talking about multiples of 6, yes, we want them to be divisible by 3. We want all the numbers which are divisible by 3. Absolutely fine. But from this, what do we want? We want also the numbers which are only even, isn't it? Even numbers is only what we want. My last place should be filled only with even. How are we going to do that? How many such combinations can we get? So think in the same case, 1, 2, yeah, 1, 2, 3, 4, 5. As we have seen, the first is done in 5 ways and the rest 3 in 6 cube ways. Into now this one place that should be my even only. earlier case, in each and every possibility, you got one even, one odd, one even, one odd, one even, one odd, 0, 3, 2, 5, one even, one odd, 1 and 4, one even and one odd. So in any numbers, you take any of the combinations, you take just one thing, finally get one thing, that is one will be even number, the other will be odd number. So obviously you want only even numbers as multiples of 6, because 6 to be multiple of 2 and 3 as well. So this place you just get one way. So my final answer here will be 5 into 6 cube into 1 only. Clear? So that is multiples of 6. So we have completed all the questions based on the sum, not the sum actually, all the questions based on how to find out the possibilities of the number when repetition is allowed and when repetition is not allowed, like all the multiples of 2, 3, 4, 5, 6 is what we have done, right? In all the both cases. So this video will be having all the, as this video is having all the questions based on the rank of the given word. Given a word, find its rank, and given a position, find the word, and then comes with all these possibilities of multiples of 6 or 3 or 5, right? Okay. So the next video is very, very important. Please do watch it and solve the previous questions. Thank you. Bye-bye.